Okay, so we have the last of our lessons on the binomial distribution, and here we're just going to have a look at what to expect in an exam situation. So this question is about the probability of a bolt being faulty. We're given that probability is 0.3, and we're told that there's a random sample of 20 bolts. We're then asked to work out these two probabilities. So the first thing that we should always do is to write down our distribution. So we can say that x, which stands for the number of faulty bolts, is distributed with a binomial distribution, and we're going to have 20 trials for our random sample of 20 and a probability of 0.3. So now that we've got this first sentence condensed into maths, we can get to calculating what we need. So the probability that there are exactly 2 faulty bolts is the probability that x equals 2. And to calculate that, we're going to use our NCR calculation, which is what we always use when we have x equals a number. So we have 20C2. That's the number of ways you can have 2 faulty bolts out of a sample of 20. Multiplied by the probability of success, which is 0.3, to the power of 2, that's our 2 successes, multiplied by 0.7 to the power of 18. If there are 2 successes, there must be 18 failures. We type that into our calculators, and we come out with this answer, 0.0278 to 4 decimal places. So that is the probability of having exactly 2 faulty bolts. Part B, we're looking for more than 3 faulty. So we're looking for x is greater than 3. Now, depending on your calculator, you'll either work this out by saying this is the same as the probability that x is greater than or equal to 4, or you'll say it's 1 minus the probability that x is less than or equal to 3. These 3 statements are all the same. To see why, we can have a look at our number line. We can say 1, 2, 3, 4, 5, just to see what's happening with the number line. If we're going greater than 3, well, that's anything 4 and above. Okay, so greater than or equal to 4. Those two are the same statement. If we're going to go the other side, which is what we have to do if you have a class whiz calculator, then we're going to use x is less than or equal to 3. So depending on your calculator, graphics calculators will do this greater than or equal to 4. Remember, it has to be or equal to. We have to change greater than 3 into greater than or equal to 4. If you don't have the graphics calculator, you'll use the class whiz, and that will be x is less than or equal to 3, and I hope you can see why. So let's get the calculator out and ready. We're going to use the binomial CD. If we go back to menu 1, you're going to go menu 7, scroll down to binomial CD, which is 1, option 2 for variable, x is 3, n is 20, the random sample of 20, and the probability of success is 0.3. We lock that in, and we have 0.1071. Now I know I'm going to be subtracting that from 1 in a second, so I'm going to store this in A, and I'm going to come back and use it. So let's go back and use it in the calculator. We'll go back to menu 1, and we're going to do 1 minus alpha A, and we get 0.8929, 4 decimal places. So now we move on, okay? Those two questions are pretty standard, pretty straightforward, and then there's always a bit of a sting in the tail. We're being asked to find the probability that exactly 6 bags, sorry, I should read out the blurb first. These bolts are sold in bags of 20. John buys 10 bags. Find the probability that exactly 6 of those 10 bags contain more than 3 faulty bolts. So we go back to the question, right? And these bolts are sold in bags of 20, which is the same size as our random sample of 20 from the first 2 parts of the question, which is telling me that we're going to have to use some of the information here in this second part of the question. So the random sample of 20 can be directly referred to as these bags of 20. Right? So John buys 10 bags. So we're now looking at a number of trials which is 10 because we've got a second separate situation. So I'm going to set up a second situation. I'm going to call my variable y this time because we've already used x. We have a binomial distribution this time where there are 10 trials because John is buying 10 bags. Now we need to work out this probability. So we're finding the probability that exactly 6 bags contain more than 3 faulty bolts. So remember, this probability is the probability of success. What constitutes a success in this question? It's the bags containing more than 3 faulty bolts. So we look to our earlier question and we say, what is the probability of a bag containing more than 3 faulty bolts? It's 0.8929. Short interruption, someone was just coming to empty the bin from the room. So we're going to use this probability, 0.8929, because this is the probability of success, the probability that there are more than 3 faulty bolts when we have them in bags of 20. So what's the question asking? What's the probability that exactly 6? So this is what we're doing. We've set up the maths, our new distribution, 10 trials and the 10 bags. Probability of success was the probability of having more than 3 faulty bolts. Now what's the probability of x equals 6? We've got 10c6 multiplied by 0.8929 to the probability to the power of 6 multiplied by 1 minus that, which is 0.1071. And that's going to be to the power of 4, and then we'll get our answer. So we have 10c6 multiplied by 0.8929 to the power of 6 multiplied by 0.1071 power of 4. And we have a probability of 0.0140. And that's our final answer. So what we've just got to be mindful of here are those little parts where there's a bit of a sting in the tail and you're asked to interpret things differently. More often than not, the sting in the tail will be using a piece of information that you calculated earlier in the question. So let's have a look at the second exam style question. Here we have 6 standard dice with faces numbered 1 to 6. They're thrown together. We're making the assumption that the dice are fair, and we're asked to find some probabilities. Now, we're going to look at this. None of the dice show a score of 6. This is telling me that we're actually working with a binomial distribution, because whether or not it shows a 6 is exactly as it says. It either does or it doesn't, giving us those 2 options, okay, success or fail. So we're dealing with a binomial distribution. How many trials are there? Well, the trials in this case are these 6 standard dice. So we're basically saying that there are 6 dice that are being thrown, so we have 6 trials. We're interested in the probabilities involving showing a 6. So what's the probability of getting a 6? It's 1 over 6. Okay? 6 trials because of 6 standard dice. The probability of success is 1/6 because we're interested in some of the dice showing a score of 6. So now that we've translated the exam question into maths, we say, what is the probability that x equals 0? And that's the probability that none of the dice show a score of 6. So in order to do that, we have 6c0 multiplied by 1/6 to the power of 0 multiplied by 5/6 to the power of 6. Okay, 0 successes means 6 failures. So we type that into our calculators. 6z0 multiplied by 1/6 to the power of 0. And you might be thinking, I know what 6z0 is, I know what a 6 to the power of 0 is. That's fine. If you type it into your calculator, you're definitely not going to get it wrong. So we have 0.3349. 4 decimal places. Okay, so once we had the math set up, not a tricky question to answer. More than one of the dice, so we have x is greater than 1. Now remember, this is the same as what we've done a few times before. More than 1 means x is greater than or equal to 2. It also means we can do 1 minus the probability that x is less than or equal to 1. And just to illustrate, we have our number line. Greater than 1 are these numbers here, which is the same as greater than or equal to 2, as we've said. And if we want to calculate that using the ClassWiz calculator, we'll do less than or equal to 1, and we'll take it away from 1. So again, you have two options. If you're using a graphics calculator, you'll be able to do greater than or equal to 2. If you're using a ClassWiz calculator, you'll be able to do less than or equal to 1. So let's use the ClassWiz, and we'll type in what we need. So we'll menu 7 again, scroll down, option 1, option 2 for variable. Our x value is 1 this time, our n value is 6, and our p value is 1/6. Now you can use the fraction button here. So we'll do 1, fraction button 6. Fraction looks like a right angle, that's fine. Press equals, it converts it to a decimal for you. The calculator is doing all of that work for you. So we've got 0.7368, which I'm going to store in A. So then to calculate this, I'm just going to go back to the calculator, back to my menu 1, and I'm going to do 1 minus alpha A, so 0.2632. And that's the probability that more than one of the dice shows a 6. So then we look at part C, where sometimes we have a bit of a sting in the tail type of a question. Find the probability that there are equal numbers of odd and even scores showing on the dice. So this time there's no mention of a 6 being anything to do with our success or fail, simply odd or even. And like in the previous question, this is asking us to be confident enough to just create a separate distribution. So our second distribution, and again I'll use y, is also binomial because it's either odd or even. Now you have to think as odd or even as it's either even or it's not even. Okay? Success being even, failure being not even. So we still have our 6 trials because there are 6 dice being thrown. But this time the probability of success is 1/2 because in the numbers between 1 and 6, 1/2 of them are even and 1/2 of them are not even. So we have 6 trials, probability of success is 1/2. And if we're saying that there are equal numbers of odd and even, then that's saying that what's the probability that y is equal to 3. So the probability that y is equal to 3 is going to be 6, choose 3, multiplied by 1/2 to the power of 3, multiplied by 1/2 to the power of 3. Okay, 1/2 to the power of 3 for our 3 evens, 1/2 to the power of 3 for our 3 not evens. So we'll just type that in. 6c3 multiplied by 1/2, 3 multiplied by 1/2. And we have the answer 5/16 or 0.312. And so there we have it, 2 different exam questions that have a little bit of a sting in the tail. And hopefully just working through a couple of them with you gives you an inkling as to what to look out for. Thanks, everybody.